Let me show you how time travel debugging works. Let's say you get a weird error like this one. What you can do now is go back to the point in time when this error happened and look at the state of the program. X not in list. What is in the list? Oh, right. We have this bracket, so 0 is not going to be in the list. Oh, what I probably meant to do is remove the item at index 0, not remove the item 0. It gets better. You can also rewind and replay the events leading up to the error. Assertion error. Okay, let's step backwards into the function call. The return value is 0. We're expecting it to be -42. Stepping backwards. So char is the negative sign, which is clearly not a digit. Oh, right, I never implemented logic that handles negative numbers. Oops. So let's set up a sign variable, and we're gonna set it to either -1 or 1, depending if we get a negative sign. Let's go. Still no. What's going on? Stepping backwards. Looks like we have set up the sign correctly. Oh, okay. You just forgot to multiply the sign into the result. Duh. What you're seeing is a time-traveling debugger prototype for Python programs. How does it work? Well, first, to run your program, instead of using the standard Python 3 executable, you use PyRewind, a customized version of Python 3. PyRewind creates a log file, which leaves a trail of everything that happened during the running of the program, such as function calls, variable assignments, and updates to data structures such as lists and dictionaries. Then, the recreate program reads back the log file line by line and recreates every historical state of the program and saves them into a SQLite database. We call this database file the history file, and it can be used to drive a debugger front end, such as this one. On the surface, this looks like a normal step debugger, but it's not executing the code line by line, but rather it's just navigating the data in the history file. Because of that, it has the ability to step backwards in time. The fact that you have access to every point in time in history gives rise to some interesting possibilities. One possibility is you can use database queries to answer questions about what your program did. Another possibility is you can reimagine what a debugger's user interface can be. This is a debugger front end called the Zoom debugger. It was inspired by the Mandelbrot set and Google Earth. Within it, you can look at a program's execution from different levels of elevation. The top level is the module, the entry point of every Python program. If you zoom in, you can see the details of what happened within. Okay, we have a hero and we have two enemies, the goblin and the wizard. There's a battle engine, a shopping engine, and then it's looping through the enemies. The goblin is the first enemy, and looks like a battle happened here. And the aftermath, hero has health 8 after the battle. Goblin has health -4, down from 6 over here. And we did some shopping after the battle, and then we do the second battle with the wizard. We beat the wizard too, and then we did some more shopping at the end, and we won. Alright, let's zoom into the first battle. Okay, so hero attacks the enemy, the goblin, and the goblin's health was down to 1 after just one single attack. How is that determined? Let's go in. Okay, so to attack an enemy, we have to first ask the enemy to receive the damage. Interesting. Here we're asking them to receive self.power. Self is the hero, and hero's power is 5. Okay, so let's go in again. So now we're inside the receive damage method of the goblin, and we're just going to subtract the points from our health. So since we started with a health of 6, now we're down to 1. That makes sense. Imagine if you could see a visualization like this while working with or reviewing a new piece of code you haven't seen before. The prototype you saw is PyRewind and is a part of the Time Traveling Debugger project, which you can find here. The concept of time travel debugging is an active area of research. There are active projects, commercial products, as well as research papers in this area. Links to these can be found on the project page as well. If you like to experience what it's like to code with time travel debugging, try using PyRewind to solve a code challenge on LeetCode or a similar site.